Let's do this problem from your lab assignment, section 11.9. They want us to evaluate the indefinite integral as a power series. So looking at this might be doable if we do a u substitution and then a trig substitution. But let's do it using a power series. So we want the power series of t divided by 1 minus t to the fourth. We'll start off again with the geometric series. 1 divided by 1 minus r. And that converges for r is less than 1 or between -1 and 1. But instead of 1 divided by 1 minus r, we have 1 divided by 1 minus t to the fourth. So the r is actually equal to t to the fourth. So that's just the 1 divided by that, but our original function in the integrand had a t. So we're going to multiply everything by t, and that means it's going to take a look at t to the 4n times another t. Now that's equivalent to just saying t to the 4n plus 1 in the power, because when you're multiplying with the same base, it's the same as adding a power. Oh, it looks like we're missing something here. Let's call this t to the 4n. And then we have t to the 4n plus 1. All right. So in our next step, we want the antiderivative of this. So that's going to generate a plus c because it's an indefinite integral. But then now we need to take the integral of t to the 4n plus 1. So that is going to be t to the integral. We add 1 to the power. So t to the 4n plus 2. So that's plus 1 plus 1. And then we're going to divide by that very same power. So that's 4n plus 2. And that's the term-by-term integration that we would have done. And then so now we want to know the convergence. So we know that the absolute value of r is what's going to converge. And so this is going to converge with the absolute value of what was r again? This is for 1 over that. So that's t to the 4n. And that's what we said r was equal to. And so this thing is going to have a radius of convergence of 1 because there's no other constants that we're multiplying or dividing. Well, sorry, t to the 4n plus 1. In either case, we don't have anything converging and diverging. Oh, it's not taking it. So let's see what's happening. 1 over this. So this is t to the 4n. Oh, I'm sorry. The n was part of the formula, and this is going to converge for just the r value. So the r itself is t to the fourth. All right, let's try that. Okay, finally took it. And so therefore the series has a radius of convergence. It's going to keep the same radius of convergence, and the series converges for the same radius of convergence. Now they don't address the interval of convergence because exactly at 1 and -1 we're not sure whether this is going to converge or diverge. And so they didn't address that particular question here, but it may be something that you might need to address in some other problem. Okay, but for now I think we're all good, and I hope that helps.